Hello everyone, this is Prakar Shastri from Acropolis Institute of Technology and Research, and today we are going to study Big Data Analytics. What is Big Data Analytics and what are its components? So let's start and let's see what we are going to study. We are going to study the introduction, that what is big data, how it is useful in day-to-day life, and what we can learn from it. The second we will study is data analytics. What is data analytics? What is big data analytics and how data analytics and big and data analytics are different. Then we'll study open research issues, conclusions, and then we'll see some references by which we will gathering the information. So let's start. What is big data analytics? So the concept of big data has been around for many years. Most organizations now understand that if they capture all the data that streams into their businesses, they can apply analytics and get significant value from it. This is particularly true when using sophisticated techniques like artificial intelligence. But in 1950s, decades before anyone uttered them big data, businesses were using basic analytics, especially in numbers spreadsheets were manually examined and uncover sites. So some of the best benefits of big data analytics are speed and efficiency. Just a few years ago, business gathered information, ran analytics, and unearned information that could be used for future decisions. Today, business can collect data in real time and analyze big data to make immediate, better informed decisions. The ability to work faster and stay agile gives organizations a competitive edge as they didn't have before. Now, let's see. So, big data means the data is unable to be handled and processed by most current information systems or methods. So, big data is a very a large form of data which needs special software to examine that. Most of the traditional data mining methods or data analytics developed for a centralized data analysis process may not be applied directly to big data. So this is true that big data is very complicated. We have to, that is raw data, we have to convert it into structured data and analyze it for the betterment of the organization. So now let's continue. A well-known definition of big data is known as three V's. So what is three V's? Volume, velocity, and variety. Now let's see what is volume. So data is huge. Volume means the volume of the data. It is called big data because it has a huge volumes of data. Second is velocity. Data is changing with time and coming with a velocity. So the new data is generated day by day. There are billions and billions of data is generated day by day, like in shopping malls, in movie theaters, and in public places. New people are coming, and billions and billions forms of data is generating every day. So it is called velocity. Third is variety. Data is coming from multiple sources in multiple forms. So like in an organization, if we visit a mall, um, if we eat pizza, then a pizza vendor has also a data in which time we are coming to a shop is also has this data. So so a single shop or a single owner can have multiple forms of data from us. So it is called variety. Now we have seen that three V's from the definition, but the latest uh, definition of data analytics has many V's. It has eight V's. So let's discuss about this eight, which are veracity, validity, value, variability, venue, vocabulary, and vagueness. So let's study individually about them. Now, first is veracity. So, not that all the data come from processing are valuable. So, unless the data is cleansed correctly, it is not wise to store or process complete data. Especially when the volume is such massive, there comes in dimensions of big data veracity. These particular characteristics are also determine whether the data is coming from a reliable source or the right fit for the analytical model. Now, second is validity. So validity has some similarities with veracity, as the meaning of the word suggests that the validity of big data means how to correct the data eh, is for its purpose. Like interestingly, a considerable portion of big data remains as unuseful, which is considered as dark data. The remaining part of collected unstructured data is cleansed first for analysis. Now, value. So, the primary interest of big data is probably for its business value. Perhaps this is the most crucial characteristic of big data, because unless you get any business insights of it, there is no meaning of other big data characteristics. Now, variability. So, in big data analytics, data inconsistency is a common scenario that arises as data is sourced from different sources. Besides, it contains different data types. Hence, to get meaningful data, that enormous amount of data anonymously and outly in a direction is essential. So, variability is considered as one of the characteristics of big data. Now, venue. So, venue, vocabulary, and vagueness. These are the newest types of data which we'll discuss later. The data satisfying set of all these properties is known as big data. As we've discussed, there are so many V's in the data, and the data which is satisfying all these values is known as big data. Now, sources of big data, how we can find big data and how it is collected. So, big in simple language, big data is equals to transactions plus interactions plus observations. First, let's take an example. We visit a store to buy something. So, as we can see in the bottom left of the slide, which is ERP, this is purchase detail, purchase record, and payment record. So, what the shopkeeper will do is to take data of our purchase detail, purchase record, and payment record. So these are the data which we have given to him. Then CRM. What is a CRM? CRM is a customer relationship management, which have segmentation, offer details, customer touches, and support contacts. Like CRM is a software which is a customer and relationship manager, which have segmentation, offer details, customer touches, and support contacts, which is shared by both. Now, web. If you are surfing on web and searching websites and watching videos, or doing a transaction, or just looking for things in Amazon, the web collects all our data, like weblogs, offer history, dynamic pricing, affiliate networks, search marketing, behavioral targeting, dynamic funnels, etc. So, uh, Google, Amazon, and all these big companies, big tech companies, tracks our data and shows us ads according to us. So this is an example of big data analytics, that someone is tracking our data or is seeing which websites we are visiting and showing us ads on the basis of that, of a internet surfing. Then big data, which is sensors, devices, mobile web, user extreme, user generated content, social interactions and feed. Now, all the compilation of these three, ERP, CRM, and web, results in big data, where our data is compiled so much that it is very difficult to segregate. And like we are seeing in the left side of the slide, then first it is in megabytes, then it is in gigabytes, then it is in terabytes, and then it's in petabytes. So, uh, when we move forward, like one from ERP, CRM, web, and then we are now reached to the big data. So big data has so much of value, so much of unstructured data, and in the bottom of the slide we can also see increasing data variety and complexity. So on each step, data complexity is increasing and variety is increasing. First only we have a purchase detail, now we have so much of web data, CRM data, and now at last we have big data. Now let's move forward. Big data challenges. So sort of 10 TB data on one node take 22 to 5 days, and 100 node cluster take only 35 minutes. So what does it mean is the sorting of data uh, is 10 dB on one node take 2 to 5 days. It means that if the node is less, if there is only one node, if you're, and we are sorting such a immense quantity of data which is 10 TB, it will take 2 to 5 days, which we cannot afford, because in today's fast paced world everything is changing, and for sorting of 1 TB data, we are spending 2 to 5 days. It will be a very loss for the company. So we have to increase our nodes, which is 10 node cluster, which is a 35, and which takes only 35 minutes for sorting of 10 TBs of data. Now let's move on to application domains of big data. That big data is on which sectors is affecting. Now first is healthcare. So healthcare analytics has a potential to reduce cost of treatments, predict outbreaks of epidemics, avoid preventable diseases, and improve the quality of life in general. The average human lifespan is increasing according to world population, which poses new challenges to today's treatment delivery methods. Health professionals, just like business entrepreneurs, are capable of collecting massive amounts of data and looking for the best strategies to use these numbers. So the average amount of data per hospital is increased from 167 TB to 665 TB in 2015, driven by enormous growth of medical images and electronic media record. So what happens with big data is that big data can accumulate data of the patients, and can see which disease is in trending in which month of the year, and can predict uh, which disease is trending in which month of the year, and can suggest changes, or can alert the hospital to be ready with some kind of precautions in their hospital. Now second is customer service. So how big data is changing customer service is that it can predict what customers want before, and to know what they want. Just like, have you ever walked into a dinner and your usual waitress appears in your regular order even without stopping to ask what do you want? The level of personalized service is what retailers try to do when they are making recommendations for customers based on past purchases. So they make those recommendations based upon the big data collection, like which customer is coming to which on which time and ordering which food. So by analyzing which customer is ordering which food again and again, can help restaurants to predict what will they order next. Now, insurance. So the advancement in technology have led the exchange of massive amounts of data that contain large volume of structured and unstructured data, referred to as big data. Even industries leveraging this big data for its own benefits. Big companies like Amazon and Starbucks use big data for supply of chain supplements. Insurance companies work to protect us and help us in certain situations. They form a pool of money taken from different clients, which also called policyholders. These companies guarantee us to give a sum of money when they require. The insurance industry is like any other industry, has also shifted towards digital platforms. So the change of data over the internet allows the insurance companies to utilize the technology of big data. So insurance company can also shift towards a digital platform, and it allows the insurance policy companies to utilize their technology for big data and predict which age group is interested in which kind of policies, and can suggest them policies on the basis of big data. So these are the advantages of big data, and how big data is useful in our day-to-day life and can be useful in the future as well. Thank you.